Swayam Prabha. Digital India. Educated India.
Hello and welcome back everyone. We are learning the basics of building construction and today we are studying the module on temporary structures. In the previous lecture, we had studied about shoring and scaffolding. Today we are going to dive into underpinning, formwork and centering. We're going to start with underpinning and then we'll move on to studying the rest of the temporary structures. So what do we mean by underpinning? This is a process of placing a new foundation under an existing one or strengthening an existing foundation. So let's say we are expanding our building or due to some reason our foundation is unable to support our existing building. We might need to alter it, strengthen it, or even strengthen the soil around the foundation. In that situation, we will have to provide some support to the superstructure while we are going about digging and creating a new foundation. So during that time, we take the help of this process of underpinning. So additional structural foundation units are added to provide support to the structure at the grade or below grade. So that is at the ground level or below the ground level. So temporary or permanent supports for an existing foundation are installed for either increasing the bearing capacity or providing additional depth to an existing foundation. This may happen if the soil has undergone some changes because of which its bearing capacity has reduced, hence requiring me to improve the existing foundation. Or let's say we have increased the load on the building or have created additional floors on top of our existing building and the old foundation is no longer capable of taking this new load that we have placed. In this case, we can go for underpinning and it will allow us to actually alter the existing foundation, make it better without destroying the superstructure that is being supported by the existing foundation. So why do we use underpinning? To strengthen the shallow foundation of existing building when we are building something which requires us to go for a deeper foundation. To strengthen the existing foundation which has settled and there might be cracks in the wall. So due to some differential settlement, changes in the soil, changes in the position of the foundation or level, there might be cracks that are developing in the wall. In this case, we might need to strengthen using underpinning. If we are supporting any tilting structures which are sinking into the ground due to the poor stability of this soil, in that case we can go for underpinning as well. To deepen the existing foundation also, if there is any structural reason because of which we have to strengthen our existing foundation, underpinning finds usage. And also if we are trying to create a basement in an existing building, we will have to take the help of underpinning. To safeguard existing buildings from settlement, when excavation is going to happen very close to this, so let's say we are doing some construction work where we will be required to dig up very close to an existing foundation level, or we are creating a trench which is deeper than the foundation level that is already existing, it can cause damage to our building. So in order to protect our building, we can use underpinning in that situation when we are doing excavation very close to it. For supporting structures, when we are altering its existing foundation or some main support members have to be added or changed, we might need to go for this process as well. If you want to increase the load bearing capacity of the foundation while we are adding new floors to an existing building, or when the original foundation is no longer stable or strong anymore, or if there is any change in the property of the soil. Now if you remember when we were learning about shallow foundation, we had learned how we calculated the depth of the foundation, the width of the foundation with the help of various formulae. Now say we had considered a certain bearing capacity of the soil for that calculation, and over time something has changed because of which the soil no longer has similar properties. That means the factors of safety and other parameters we had considered while calculating the size of the footing is no longer applicable. Probably now we need a deeper foundation. So now we cannot destroy the existing building. While protecting it, we have to undergo some amount of transformation in the foundation level. That is where underpinning comes in usage. Underpinning is also needed when there is uneven settlement of soil, which is either caused due to unsymmetric loading of the building, or if there is uneven bearing capacity of the soil beneath the existing foundation. Maybe there is spreading of tree roots, a very common phenomena below the existing foundation that can definitely cause harm to the foundation and the stability of the overall building. There might also be some amount of problem with the consolidation of the soil. Soil undergoes changes and in its properties, in its chemical composition, in the way it settles over time, that might require me to undergo some changes in my foundation. When there is an additional imposed loading on the building due to the addition of new floors or services also, we can go for this. And when there is a lowering of the adjacent ground near the existing foundation, underpinning is required. So we now understand why we have to go for underpinning. So now let's see how we can actually go about it and what is the process involved in the same. Underpinning can be done by load transfer. That is, we are transferring the load of the superstructure through certain members into the ground. We can also go for soil treatment. That is, instead of altering the foundation or the structural components, we are actually consolidating or strengthening the soil which is surrounding the structure to increase its bearing capacity. Or we can go for a combination of both. That is, load transfer and soil treatment together we are doing for underpinning. So what happens in load transfer? So let's say additional structures are being placed that can support and transfer the structural load to a stratum that is more suitable for providing support. So right now the foundation is at a level where it cannot take additional support from the stratum. So we are going to cross that, go to a level where there is more stability in the soil, then that is where we anchor the building from. So when we are adding structures into the ground for this transferring of load into the stratum, we are doing the process of load transfer for underpinning. For soil treatment, we are not changing the existing foundation, but we are changing the properties of the soil which is surrounding this particular foundation to make it stronger. So before we undertake this task of doing underpinning, there are certain preparatory practices, certain precautions we have to take. So first of all, we will definitely have to notify nearby owners, landowners, our neighbors about the planned work, and we give a complete detail about the task that is going to be done and what are the necessary temporary structures like shoring that have to be added on the external facade of our superstructure to ensure that the upper building is protected while we are changing anything underneath. So if it is such that we are at a position where there is a possibility of a wall to topple over, we would definitely want to give it some temporary support in the form of shoring before we start digging around in the foundation. Now we have to conduct a very thorough examination of the area, the structure that has to be supported, or any other buildings or structures that are close by that could possibly be impacted because of the fact that we are digging and making some changes in the foundation. Now, if there are any defects in any of these parts, we should definitely note it before starting the process. It is important to place indicators over cracks. So, if let's say due to uneven settlement in the soil, some cracks have developed in the structure or the facade, and we are going for a new foundation because our soil is settling and we are having structural damages being formed. In that case, when we start doing the process of underpinning, let's say due to this subsequent movement, new cracks may form. So it should be important for us to signify which were the cracks that were formed beforehand and which are the new ones that are appearing because of this underpinning process that we are undertaking. So we have to definitely document and clearly mark all the previous cracks so that no new ones emerge throughout the construction transformation. Now, before beginning any underpinning work, a comprehensive investigation should be conducted to determine the source of the settlement, if any settlement is happening in the ground, and what correction action has to be taken, anything that needs to be taken before we take up this process. The loads on the building to be underpinned should be reduced. So let's say not everything in the building, in the upper superstructure can be removed. Many of it is permanent and the self weight of the wall and slabs and structural members are not something we can alter. But there are a lot of other loads, live loads that are placed on the building which we can remove. So that additional imposed load we can definitely get rid of from the upper floors of the building while we are doing the propping or the shoring in the building to ensure that not a lot of additional unnecessary support is created on this foundation while we are trying to make changes in it. Any serious services which are very close to the building, let's say water supply lines or sanitation lines or any other form of services that have been placed very close to the building, we have to identify them, properly mark them, carefully expose them such that while doing the construction work, the masons are very clear about what are the different service lines nearby. Otherwise, accidentally, they might end up damaging it while doing the excavation, trench work or other works below the ground level. So now that we are well aware of what underpinning does and what is the situation in which we can use underpinning and how we can prepare for it, let us start learning about the various methods of underpinning. Before we determine what is the suitable method of underpinning applicable to our construction, we have to see what are the foundation loads that have to be supported, what is the allowable structural movement, and what is the magnitude of deformations that I could possibly allow and what is expected to happen during this process. We will definitely have to study the soil conditions in pretty much detail, knowing what is its bearing capacity, what are its challenges, its properties, its physical surroundings, vegetation, etc. that is impacting it, and every other aspect that might alter the health of this foundation. The groundwater condition also has to be studied, because if it is a very high groundwater table where just a little bit of digging exposes water, we cannot use any and every type of underpinning, as it will become clearer when we study the methods. So a specific type of underpinning will have to be selected because there's a lot of water the moment we start digging trenches. What is the way we can access the foundation? If we do not have very clear access to the foundation, we'll have to select a method which allows us to do the underpinning with minimum access to the foundation. Now, what are the potential environmental hazards? If there is any seismic loading in this area, if this is an earthquake prone area and there's possibility of earthquakes, we need to study all of these situations in detail before we go ahead and select the type of underpinning which is suitable for our context. So the various types of underpinning that we can go for include something called the pit method, very popular method, the pile method. We can do a special process for the underpinning to walls. There's something called jack pile underpinning, followed by needle and pile underpinning. We also have the pine fort stool method of underpinning. Then the root pile or angle piling underpinning columns. And there are other miscellaneous approaches which, unlike doing the process of load transfer through underpinning, can also do soil treatment. So in this case, we are not doing anything to the foundation, but we are making some changes to the soil which is surrounding the foundation to make it better at supporting the load. So we're going to study each of these types of underpinning now one at a time in detail. And we are going to start with the pit method. Now here the existing foundations are enlarged or deepened by removing soil from beneath the foundations and replacing it with concrete reinforcement and a ground material. The structure may also be temporarily shored to prevent settlement. So raking shores can be used to support this structure. So how do we go about the pit method? Now here the entire length of the foundation to be underpinned is divided into different sections. Now these sections are about 1.2 to 1.5 meter in width, and we select alternate sections when working. So if this is the first section, we do not take the next section, we take the section after that. We come back to the sections left in between later on. So one section is being taken up at a time. You do not want to go about creating multiple openings throughout the length of the wall that might compromise the stability of the superstructure above. So we are going to take one section at a time, and the sections are going to be spaced apart so that not a continuous large stretch of a wall or superstructure is being exposed to this process. Now for each section, a hole is made in the wall right above the plinth level, and a needle is inserted into the hole. So we've already come across needles before when we were looking at dead shores. So we know that needles can be inserted through the wall. Here also a needle is being used to support the superstructure while we create changes to the foundation beneath. Now these needles can either be made up of timber or they can be made up of steel sections. Now bearing plates are placed above the needle to support the masonry above it. So this is the bearing plate. We have inserted a needle. On top of this needle we have a bearing plate. This is where the wall will come and rest. So this helps us create a disconnection between the upper part of the superstructure and the lower part with the help of this needle. Now this needle is supported on either side of the wall on clip supports and screw jacks. Now if we are at a situation where both sides of the foundation we can provide jacks, then this needle will be supported on both ends with the help of jacks. If we are in a situation where we can take the help of an existing column maybe inside the building, then in that case we can use only one hydraulic jack and support the needle on one end on a structural member and then do the alteration in the foundation in the other end. Now the foundation pit is excavated up to the desired level and we do the new foundation laying. Now when the work of one section is over, the work on third section is taken up. So 1 and 3, we do not take up the next section. This portion we are going to leave for a later time. Now if an interior strong column is there or if the foundation is to be extended only to one side, cantilever needle beams may be used. This is the example which we were talking about. And here we can just place one central fulcrum. So the jack in this case will be placed in between the wall. This is the wall in which the foundation has to be altered and the column from which additional support is being taken for the needle beam. So some of the points that we need to consider when going for the pit method of underpinning includes: in the first round alternative sections are taken up, next remaining intermediate sections are taken up. So we come back to the second pit after finishing up the third pit. At a time only one section should be taken up. So we do not want to do simultaneously section 1 and 3. We want to do it one at a time, then come back to section number 2. The work is started from the middle of the wall. So we do not start at the edge or the corner. We start at the middle of the wall and we start extending to in both directions of the wall along its length. Now proper timbering of the foundation trench may be done if the new foundation that one is adding is deeper than the previous foundation. We definitely have to do further excavation beyond the level of the previous foundation, create proper trench. Proper timbering has to be done in this foundation trench so that we can do the construction uninterrupted. The needle beams should not be removed before the new foundation has gained strength. So the moment the construction is done and we have moved on to an alternative section, we do not remove the needle from the previous section. We allow this foundation to gain its strength, settle, then we remove the needle. It is preferable to do the new foundation work in concrete. Now cement mortar should be used to close the needle holes in the masonry. Definitely after the construction work is done, underpinning is done, we remove these needles, there will definitely be holes in the walls at the plinth level. So that is not something we want to leave. We definitely want to cover that up with appropriate usage of cement mortar. The next method of underpinning is called pile method. Now pile underpinning is used when the loads from the existing foundation need to be transferred to the stable soils at a greater depth. So shallow foundation in that case will not be suitable. We need to reach a deeper strata. So for that we go for deep foundation type pile. Now there are usually some sites in which there are variable soil conditions and there is very limited access to the foundation because of the shortage of area or space around the building. So in that case also we can opt for the pile method. So what happens in the pile method? In the pile method, piles are driven at regular intervals along both sides of the wall. So if this is the wall, that needs to be supported. Here we are adding piles on both sides, and there is a needle cap. This pile cap is going to act as a needle which will support the superstructure and transfer the load that is coming on the superstructure to the piles on both sides. Now these piles are connected using concrete or steel needles which are penetrating to the wall, and these beams are also acting as the pile caps as already discussed. Now this method is useful when the soil type is very clayey and when the area is very waterlogged. So in that case, definitely creating foundation trenches, doing proper timbering of that foundation trench and doing the underpinning with the help of pit method will be very difficult, because in a waterlogged area, the moment we start creating pits or excavate the earth, we are going to have issues of waterlogging in these areas. So to prevent that, we go for the pile method instead of the pit method. So we have to know which type of soil we are dealing with and what is the height of the water table in our area before we select any type of underpinning. As we were discussing, there are some factors that we have to keep in mind while selecting the method of underpinning most appropriate for our context. So the next type of underpinning that we need to take a look at is the one done for walls. So this is undertaken in short lengths of 12 inches to 18 inches only. Now the holes are cut at regular intervals in the walls, and of course needles resting on sole pieces at the ground level, they support the entire wall weight. So this particular self weight of the wall, that is being supported with the help of this needle that has been inserted through a hole in the ground in the wall, and it is supported with the help of these jacks and crib supports. This needle may either be made up of timber beam or it could also be a rolled steel joist. Now wooden bearing plate has to be inserted between these beams. It may be a rolled steel beam or a timber beam, but above this we have to have a wooden bearing plate on which the masonry is going to come and rest. So this is the position in which the bearing plate has to be placed here. This is going to protect the masonry from being crushed when it comes and rests on top of the rolled steel joist or the timber beam that we have used as a needle. So what we are doing here is we are supporting the existing wall with the help of raking show. So this is one additional lateral support that we have given. The internal floor area has also been supported by a floor strutting, very similar to what we were doing in dead shores. We had given additional support to the floor slabs inside the room. Then we are going to create a hole at the needle beam, put some bearing plate on which the masonry will come and rest. Now we have the freedom of altering the foundation underneath in this pit. For easy workability, a pit of sufficient width and depth is excavated along the length of the wall. Replacement of the foundation of a wall is carried out in small sections of 90 to 120 centimeters at a time. Now when the long walls are to be underpinned, the work is started from the center of the wall and simultaneously carried out in both directions, just like we were already doing in the pit method. The needles are removed after the new work is completely set and the masonry has gained full strength. The next type of underpinning is called the jack pile underpinning. This method can be used when the depth of a suitable bearing capacity subsoil is too deep and making traditional underpinning is very costly. In this case, what we are doing is, it's a very quiet, vibration-free operation which uses the dead weight of an existing structure as a reaction to install the pile. So we are trying to insert a pile into the ground. Instead of using any heavy pile driving equipment or doing any vibration on site, we are actually utilizing the weight of the existing structure to provide us the power to push this pile into the ground. The pile depth may be adjusted according to the underlying soil. We have to definitely test the soil and understand what is the necessary depth required to reach the right strata where we can stably support our superstructure. The existing foundations must be in a good condition since they span over the heads of the pile caps, which are cast directly onto the jack pile heads once the hydraulic jacks are removed. So this is where the hydraulic jack comes in. Once this is removed, we want the foundation to rest well on the piles that we have just driven. So the next type of needle and pile underpinning involves the condition of existing foundation. If we are finding it unsuitable for traditional or jack pile underpinning, we can go for this method. So in this method, we are using the arching effect of the brick bonding to transmit the load into the needles and ultimately to the piles. Now the brickwork above the existing foundation must be in a very stable condition, and we are going to use the arching effect of the brick bond to help transfer the load. Now the piles used within this method are usually very small diameter board piles. So we can have a situation in which the board piles are on both sides of the wall from which the load is being received, the wall where the underpinning is being done. In case we are retaining the existing foundation and we cannot move in this direction, only in one particular direction we can provide additional piles, we can go for the piles in the same direction as well. The Pineford stool method of underpinning is another method which can be used where the existing foundation are in a poor condition, and it enables the wall to be underpinned in a continuous run without the need of needles or shoring. So here, unlike the previous methods where we are taking alternative sections, we are supporting the wall above with the help of needles, then we are going about altering alternate sections starting from the middle of the wall to the sides. Here, because of this method, we can actually underpin in a continuous run. Now the reinforced concrete beams are formed by this method may well be adequate to spread the load of the existing wall, or it may be used alongside other forms of underpinning, such as we are using a combination of the traditional and jack pile formation. So what we are doing here is, in stage 1, we are going to create holes in the wall to receive the steel or precast stools. So we are creating these holes. Here we are going to place these stools. These stools are inserted in the second stage, and they are pinned to the soffit of the brickwork. So here we've created an opening in the brickwork, so that is where we will fix our stools. And in the third stage, the brickwork between the pinned stools is removed, and we leave the wall to be supported on these pinned stools. We can use precast concrete spreader pads to ensure that this member doesn't come directly on the masonry and crush the masonry. We can use a bit of a spreader pads in between. It will help us transfer the load smoothly. The next type of underpinning involves root pile or angle piling. This is an alternative to traditional underpinning. It is time and cost effective as it uses modern concrete drilling equipment. So it is used when the sound bearing strata of the soil is located within a few meters of the surface. So we do not need to go very deep in to get the proper strata needed to support our existing foundation. So here the wall stability is achieved through lining reinforced concrete piles which are inserted in such a way that they are in pairs and in opposing angles. So there is one pile in this direction, another which is crisscross in the opposite direction. They are in pairs placed at regular intervals. This spacing of course can be determined with the help of studying the soil type, the existing condition, how much damage has already happened. Certain factors will tell us what is the distance between this arrangement of double piles that we are placing into the ground. The existing floor, wall and foundation are pre-drilled with air flushed percussion auger, giving access for a steel lining to be driven through the subsoil until it reaches the strata that is needed for support. Now this for all the various types of underpinning that are used for load transfer. Now let's take a look at soil treatment type of underpinning. Here we are not looking at any change in the existing foundation. We are not drilling the wall. Rather, we are trying to strengthen the soil around the existing foundation to give it greater capacity to hold this building. So the first thing we can do is something called cement grouting. Now this is used for restoring slabs and pavements that have begun to settle because of the changes in the soil. Now cement grout is forced inside holes drilled into the soil in the slab. Now the pressure is maintained until the grout has set. So the first method, cement grouting, here we are using cement grout to actually provide strength to the surrounding space to help us better support the existing foundation. In chemical composition or chemical consolidation, chemicals are used to consolidate the soil under the existing footing. So perforated pipes are driven in an inclined direction into the ground. Sodium silicate solution is injected through these pipes. While withdrawing the pipe, calcium chloride is injected through these pipes. So what we are doing is we are using various chemicals like sodium silicate, calcium chloride to alter the soil condition rather than actually changing our existing foundation like the previous load transfer methods which we were studying. We can also go for the process of freezing, in which freezing pipes are driven below the existing footing to help freeze the soil in order to enhance its stability. Vibroflotation is a vibrating device that is used to vibrate the sand and increase the density of the sand. This helps us in increasing the bearing capacity of the soil, and this method is used when sand is granular or sandy. So we are basically strengthening the soil, consolidating it to give it better bearing capacity, better way of supporting the existing load. So that was all we had to learn today about underpinning. So let's move on to the next part of temporary structures called formwork. Formwork or shuttering is a temporary ancillary construction which is used as a mold for a structure. The concrete is poured into this mold and left to harden and settle, after which it is removed. So what formwork is essentially a dice. So let's say we are trying to create something with concrete in a particular shape. The container or the dice within which this is to be done is the formwork. Now the cost of formwork may be up to 20 to 25% of the cost of structure in case of buildings. So it's pretty expensive. Now this percentage is higher if other civil constructions like bridges are being done, especially because bridges will have a lot of angles and curves which need a lot of support from the formwork. Let's learn some common terms which are associated with formwork. The first is called stripping. It is the operation of removing the formwork after the concrete has set. The second term that we need to know is panel forms. These are the components of formwork that are removed and then reused for the forms of another part of the structure. They can be reused several times. So basically the main chief components of formwork are this type. The stationary forms are forms that are made up of individual non-standard members and the structures that have no repeatability. So let's say we are making a dice which is unique. A certain part of the structure has to be made which cannot be replicated elsewhere. So that formwork cannot be reused again because it's specific to one part or one member. So those are called the stationary forms. They also consist of formwork for structural members which cannot be stripped. Formworks can be further classified based on the material that we commonly use. We can use wooden, plywood, steel formwork, combined wood and steel. We can have reinforced concrete or plain cement concrete to actually do the formwork as well. Now timber and steel formworks are most commonly used and we will take a look at them. Let's start with timber formwork. The common defects that happen in this case is that timber can warp. It can swell up and shrink due to environmental factors, especially if it is exposed a lot to moisture. These defects can be overcome by applying water impermeable coatings. So this is to protect our formwork or timber members from imbibing water and undergoing some changes in its shape and structure. Now the coating prevents the shuttering from adhering to the cement concrete also, and it also helps us in preventing some amount of stripping. You might have noticed in construction sites many a times plastic sheets are also used as a layer in between this formwork and the cement that is being poured into this formwork. This allows us a easy stripping away of the timber planks after the concrete has set. Of course, then we will also have to peel off the plastic sheets when they are no longer required, because they will be adhering to the side of the concrete. Steel formwork majorly is used for works where everything is mechanized. Steel formwork can be used for different purposes. It is very easy to strip. It ensures a very even and smooth concrete surface. It possesses very greater rigidity and stability. It is free from the problem of shrinkage or distortion, which is very common in timber. But it is of course comparatively more costly, and it will have to ensure an initial higher investment. Now, any good formwork should have certain requirements. First of all, the material of the formwork should be cheap and it should be suitable for reuse several times. It should be practically waterproof so that it does not absorb water from concrete. Also, its shrinkage and swelling should be minimum. It should be strong enough to withstand all the loads that are being placed on it, such as the dead load of the concrete and the live load during its pouring, compaction and curing. It should be stiff enough so that deflection is minimum. Otherwise, the shape of the structural member we are creating will be altered. We do not want a column which has slight bulge in the center or the slabs having some form of sagging. So, to prevent that, we have to ensure that our formwork does not undergo too much deflection when the weight of cement that is being poured into it is added. Formwork should also be as light as possible. The surface of the formwork should be smooth and it should allow easy stripping. All joints of the formwork should be stiff so that lateral deformation under loads is minimum, and they should definitely be leak proof. Otherwise, the concrete which is being poured will leak from the sides and will be causing distortion and definitely a bit of a wastage of material in the construction site. The formwork should rest on non-yielding supports. So, we want to ensure that the formwork is stable in its position up until the point that the concrete has dried up. Indian standard on formwork is the IS code 450/2000. It has most of the instructions needed to ensure that the formwork that we are using is up to the mark. The formwork shall be constructed according to the designated shapes, lines and dimensions is what the code specifies. They should remain sufficiently rigid during the placing and compacting of the concrete. Formwork should be sufficiently tight to prevent loss of liquid from the concrete. It should be cleaned of chippings, savings, sawdust, which should also be removed from the interior of the forms before the concrete is poured. The formwork in contact with the concrete shall be clean and thoroughly wetted or treated with an approved composition. Care should be taken that such approved composition is kept out of the contact with the reinforcement. In no circumstances forms shall be struck until the concrete reaches a strength of at least twice the stress to which the concrete may be subjected at the time of striking. Wherever possible, the formwork should be left longer as it actually helps in the process of curing of the concrete. So, one should not be in a hurry to remove the formwork as soon as they feel that the member being created has dried up or cured. Some time should be given. It is best to let it rest for a significant amount of time while other construction works are being done, and one returns at a later date when the concrete has stabilized, has cured sufficiently, and then the formwork can be removed. The code also specifies that all formwork shall be removed without such shock or vibration as would damage the reinforced concrete. Before the soffit and struts are removed, the concrete surface shall be exposed where necessary in order to ascertain that the concrete has sufficiently hardened, and proper precautions have to be taken to allow for the decrease in the rate of hardening that occurs with all cements in cold water. It is generally desirable to give forms an upward camber or curve. So when we are placing the formwork, we want to give it a bit of a slight upward curve. This prevents sagging of the beams. Due to the deflection of these members, certain amount of sagging will always tend to happen. To prevent this, we want to give it an upward curve or camber whenever possible. But this should not be done unless allowed for in design calculations of the beams. Formwork shall be constructed such that the internal dimensions are within the permissible tolerance specified by the designer. So whatever is the space inside, these dimensions have to be according to the specifications of the designer. We have already learnt what the term stripping means. It's the removal of the formwork post the drying of the concrete or formation of the shape that we wanted. So for different parts of the building that we have created using this formwork, the stripping time is different. For example, for walls, columns and vertical sides of beams, at least 24 to 48 hours have to be given before we can strip it. For slab soffits, the props left under, that is, if we have a slab and this is supported with the help of a prop, this is the floor. This, if the floor prop is left underneath this slab soffit, 3 days we can remove the stripping. For beam soffits, at least 7 days we'll have to wait. Removal of props to slabs are such that if the slab is spanning up to 4.5 meters, 7 days we can do stripping. For more than 4.5 meters, we have to wait for 14 days. Similarly, for the removal of props to beams and arches, if it is up to a span of 6 meters, 14 days is the waiting time. For more than 6 meters, we have to wait for 21 days or more. Now, shuttering looks very different depending upon whether we are going for columns or other parts. So, shuttering for column consists of the following components. First of all, we have sheathing all around the column periphery. We also have side yokes and end yokes. So, these are brackets or braces that are clamped together to hold the column formwork in position. Then we also have wedges, bolts with washers, etc. that are used. So what we are doing here is we have a sheathing around the member that we are creating. We have side yokes which are holding this in position, and we are using bolts and washers on the edges to hold them in position while we are creating the formwork within which the concrete can be poured. So if you are going for an octagonal column, this is how the sheathing will be arranged. Again, we will have yokes. We have spacers in the corners to maintain this octagonal shape. We are going to provide cleats at the angles and different wedges that will be used to help hold these washers and bolts connecting the yokes in position. Similarly, for a round column, we will have sheathing, and this will be connected with the help of cleats in corner positions and bolts holding the other corners. Shuttering for the columns will be such that the end and the side yokes consist of 2 numbers each and are suitably spaced along the height of the column. So they are connected by 2 long bolts of 16 mm diameter, and 4 wedges are inserted at each corner between the bolts and the ends of the yokes. So this is where the wedges will be placed. For the shuttering for beams and slab of the floors, the slab is continuous over a number of beams, and the slab is supported on 2.5 centimeter thick sheathing laid parallel to the main beams, supported on wooden battens laid between the beams at suitable spacing. The side forms of the beam consist of 3 cm thick sheathing, and the bottom sheathing of the beam form may be 5 to 7 cm in thickness. So what we are doing is we are using sheathing around the slab and the beam to create the shape within which we can pour the concrete and make the requisite size and shape of the structural member. Beneath this, we are using something called a head tree here. This is the member which is now going to be connected and supported with the help of braces for support. These posts, or also called props, will be resting on sole pieces and wedges in the bottom at the floor level. So whenever we are adding props, above the props we have brackets to hold them in position, above which we are using cleats to support the ledger. This is the ledger. On top of the ledger, we have battens which are spaced at regular intervals, above which the sheathing is placed, and that is where, on top of which we will create the slab. The end of the battens are supported on ledger, which is fixed to the cleats throughout the length. Now the cleats are about 10 cm cross 2 cm to 3 cm and fixed to the side forms at the same spacing as that of the battens. The shore or post is connected to head tree through cleats. This is the head tree. At the bottom, 2 wedges of hardwood are provided over a sole piece. When we are doing shuttering for stairs, the sheathing or decking for the deck slabs is carried on cross joints, which are in turn supported on raking ledgers. Now the ledger is generally 7.5 cm to 10 cm in size, and the cross joints may be 5 cm to 10 meter in size, 10 cm in size, and they are suitably spaced out. The riser planks are 4 to 5 cm in thickness, and they are equal to the height of the riser. The planks are beveled to the bottom to permit whole of the tread face to be troweled. So here we will add struts at regular intervals held in position with cross joints to create the shape that we want. Stiffeners are also placed midpoint of these risers. We will take a look further at how the riser planks are placed only after the reinforcement has been fixed in position. The outer ends of the riser are carried by a cut string made up of 5 cm thick plank. The wall ends of the riser planks are carried by 5 cm cross 10 cm hangers secured to a 5 cm board fixed or strutted against the wall on which the staircase is to appear, and a stiffener joist of 5 cm to 10 cm is placed in the middle of the riser planks. This is the stiffener we were talking about. So these cross joints are supporting this ribbon, this ledger, on which the decking is placed, the risers are being created. These riser planks are also being given additional support with the stiffener placed in the middle. If we are doing shuttering for walls, for fixed walls, the boarding may be 4 to 5 cm thick for walls up to 3 to 4 meter height. The boards are fixed to 5 cm cross 10 cm posts. These are known as studs or soldiers, and they are spaced up about 0.8 meters apart. Horizontal wallings of size 7.5 cm cross 10 cm are fixed to the post at suitable intervals, and the whole assembly is strutted using 7.5 cross 10 cm struts. So these are the struts. These are incoming members which are supporting this entire arrangement that has been created with the help of the railings and the studs. The 2 shutters are kept apart equal to the thickness of the wall by providing a 5 cm high concrete kicker at the bottom and by 2.5 cm cross 5 cm spacers which are nailed to these posts. Now if we are dealing with moving walls, in these the forms are made up in panel size of 0.6 meters to 1.8 meter so that the handling and the stripping is easier. 15 millimeter plywood is commonly used instead of boarding. the panels are erected in such a way that the lower panels can be removed when the concrete is hardened and we can use it higher up in the wall. So as we move from bottom to top, we can remove the members from the lower half and use it on the upper half. The framing of size 5 cm cross 10 cm is used to ply the shutter, and the panels are fixed to a central and two ended struts. Each stud consists of two pieces of timbers 5 cm cross 15 cm blocked apart, and the end strut of each panel secures adjacent panel. So this was about shuttering. Let's talk a little bit about the centering process. Now this is the part of formwork which supports the horizontal surface. So when we are supporting horizontal surfaces, that part of formwork is called centering. For example, slab bottom, beam bottom, arches, etc. It must be strong enough to carry the heavy load of concrete brickwork or masonry without movement or distortion. Now in case of arches, it must be so designed that the upper surface adequately supports the type of masonry or brick which is being used to make the arch, and it must be supported in such a way that it can be easily removed without disturbing the stability of the structure above. We had studied the centering of arches in detail when we were learning about masonry. Just to remind you all, for the construction of arches, it is carried out in 3 steps. First, we do the installation of centering, in which the centering is a temporary structure required to support the brick, stone or concrete arch during its construction till it has gained sufficient strength. Now usually it is made up of timber or steel, and wooden centering is the simplest and cheapest option for a moderate span. So this usually comprises of post or prop, which is the vertical member supporting this at the corners. Then we use wedges on which we support the turning piece. The laying of an arch involves the installation of centering, then skew backs are prepared. Voisers are then arranged in proper and required forms, starting from the skew backs and proceeding towards the crown. So we start at the edge and we move towards the crown or the top. When finally the keystone is inserted, all the voisers will be held in position. Then finally, once it is settled, we will remove the centering. So when the arch has developed sufficient strength, the centering will be removed, and no load should be placed on the arch unless the centering has been removed. So just to recap what we have learned today, we started with underpinning, where we learnt that there are various methods of underpinning called the pit method, pile method, underpinning to wall, jack pile underpinning, needle and pile underpinning, pineford stool method of underpinning, root pile or angle piling underpinning, where we have cross formation of piles, and other methods which are used to support the soil surrounding this foundation. Then we learnt about shuttering, where we talked about column shuttering, how they are placed with the help of yokes and bolts, and sheathing is placed at the shape in which we require the column to be. How shuttering is done for beams and slabs using different spacers and different members of specific sizes. How we do the shuttering in case of stairs, and for walls, both moving walls as well as fixed ones. And then we learnt how centering, which is the horizontal type of formwork, is done for arches. Before this, we had studied in the previous lecture other types of temporary structures called shoring and scaffolding. I'm sure you've gone through that lecture as well. So these are some of the books we can refer to further study this in detail. So with this, we end the various types of temporary structures that are used in our construction. Thank you so much for tuning in.